Okay, today is called linear programming, but thankfully it starts off with something much simpler than linear programming. Uh, do you remember the kind of problems where you would shade on one side of a line? You'd graph something like this, and then you'd shade above it or you'd shade below it. It was like a combination of I don't know, simple ones where you have a number line and you'd go, okay, let's say this is 0, 1, and 2. And I said, if it was bigger than 1, I'd shade this way. Kind of remember doing those when you were, I think that was like 6th grade or something. Say x is bigger than 1, you'd shade like that. But then you learned how to graph things like y equals 1/2 x, let's say plus 1. And then we combine the two, which is like you graph this and then you shade. And if this is bigger than that, then you'd shade above that. Bigger than or equal to means the line gets included too. All right, so there's a real quick summary. The only thing that's different than that, you've already done all that. This is all totally review. What's new about it is that you graph like 3 things. And let's say I shade underneath this one. And let's say I say we're talking about production of electric cars, and you are the next Elon Musk, and you are selling cars. Of course, you can't sell negative cars, so it has to say above 0. And that's called a common sense constraint. And then you get how this is where they all overlap? All 3 lines all overlap right there? Then that's the new stuff that you're going to be doing. Today, we're really just doing that. We're just overlapping lines. You're going to shade this way, shade that way, see where they all overlap. Okay? But what you're going to go to by the end of the week, it's a really short unit, because once you've got this, then this is called optimizing. You figure out if that spot, or that spot makes you more profit. It's always the corners. So one of those corners will be the best for your company. It'll make you the most money. Do you get sometimes that companies make more money selling this than they do selling that? Like at Best Buy, you've probably heard this, but they make a lot more money on selling their cords than they do on actually selling like a TV set. I know that sounds crazy. They sell you 1 cord because their cost on the cord is like $3 and they sell it to you for like 20. They can make as much money selling 1 cord as selling you a whole TV set because they don't have a big markup on TV sets. Okay, so anyway, if you figure out which of these combinations of things, like this is an X direction, this is a Y direction, whether this spot, or this spot, those are called the vertices of the feasible region. You figure out which of them has the best profit. There, that's the whole unit. Now I'm going to go back and like teach you one little step at a time. All right, so do you get that greater than looks like this? Lord help you if you don't know that. Okay, but I actually, it's true. A lot of kids are like, I don't know what sign that is. I can only tell you that the numbers over here are bigger because the alligator eats the bigger one. You know what I mean? But that sign's called greater than. And it's kind of nice because the sign that looks like an L is actually less than. So if it looks kind of like an L, it's a less than sign. Again, I'm amazed at how many kids, I probably get 20% of the kids that wouldn't know, except that I just said it, which sign that is. If I don't have numbers in there, they're like, I don't know. Is it greater or less? I don't know. But the way I would tell you is you can put numbers in and then just read it. 8 is greater than 1. If you know that the alligator is going to eat the bigger one, right? It is a greater than sign. Or the other way to say it is, if it looks like an L, it's a less than sign. So what's that? Less than or equal to. I normally like to put the signs on the other side. Do you know if I switch this around, I'd have to switch the sign around too? Does that ring a bell? Okay. So then if I say A is greater than or equal to 8, could you believe that that might be like the ages allowed for log rolling? If you're going to learn how to be a log roller. Do you know they actually teach that now? One of our teachers that teaches this class actually in a different hour, she teaches log rolling. So you can jump in the pool. They have these fancy logs that are meant to go in pools, and you can learn how to be a log roller. Anyway, if the ages was greater than or equal to 8, that means could the kid be 8? Yes. Could the kid be older than 8? Yes. Could the kid be 7? No, because then the age wouldn't be, see, if I put a 7 in, it does not work. 7 is not greater than or equal to 8. All right. What if I was going to graph A is greater than or equal to 8? Well, I'd put an 8 on my number line, and then a number on each side of it just to show which way they're going. And then I would circle the 8, and then how do I say greater than or equal to 8? Yes? Yes, because of the or equal to 8 part, yep. Yes, that direction. There you go. That's how you graph A is greater than or equal to 8. How do I, on an XY graph X is greater than or equal to 8? Well, first of all, you got to figure out where X is 8. Do you get this as the X-axis down here? Do you get that X would be 8, like maybe there? And then the line X equals 8 becomes important. That's where X equals 8. Now, since this is greater than or equal to, I have a solid line here. If it hadn't had an or equal to, I would have used a dotted line. And then greater than, I just shade on this side of the line. Now, some people like to do that by actually shading in everywhere. But my advice to you is just do what I just did. And I know you have an iPad, and it has a highlighter. If you're going to highlight, just highlight a little bit on the one side of the line. As in, I've got a highlighter too. See if I can find it here. That's not it. I think it's in there. And I think it's choices there. Highlighter. And I go like that. Just shade a little bit on one side of the line. I'm telling you, when you get these final graphs and they got 3 lines drawn and they're all being shaded, it gets so complicated if you shaded everything. Just shade a little bit on one side of the line. Granted, you could shade everything on that side of the line. It just gets really messy when you're trying to combine 3 graphs. All right, if you understood that, would you please sketch for me what y is less than 3 should look like? Hint, start with the line y equals 3, but don't actually use that line. That's where the line is 3. And if I used a solid line here, I'd have a problem. Dotted line. Why? Because y equals 3 would be the solid line. Get the difference? Y equals 3 would have been this. We have y is less than 3. So there's where 3 would be, but we can't be 3. We have to be less than 3. Does that sound like below or above to you? Below. And my advice is just shade a little bit below it. If you're going to use a highlighter, use your highlighter and just go, hold on, just shade a little bit below that line. Because why? Because later we're going to have another line here, and it's going to be like shading underneath that. And we have another line here, and it's got to be above that. And if you shaded everywhere, you'll not be able to tell where they all overlap. But I can still see from my little marks that my final answer would be something like that, where they all overlapped. Okay, so that's where we're headed. Would you please graph this? Y equals 2x plus 1. Just plain old-fashioned y equals that to start with. In a second, I have it shaded. Graph that. In case you forgot mx plus b form, the slope's 2, starts at 1. Right there, starts. Slope 2, rise 2, run 1. Rise 2, run 1, rise 2, run 1. And there we go. And then, now what if I said less than or equal to? What does that feel like logically? This one is intuitive. It makes sense. Does it feel like you should shade below the line or above the line if I say less than? Below, and you're right. Don't think of it as left or right. That'll mess you up. Think of it as above or below the line. There we go. Now, do you get if I asked you to graph another one on the same one? You could do that on the same one. Graph y is greater than or equal to 1 on the same graph, on the same xy axis. Did you see that as here's where y equals 1? And notice I used a dotted line to start with, but I'm going to make it solid now because I'm realizing, oh, it could be equal to 1. So there's the line y equals 1. And then if it's bigger than, that means above. So again, I would just shade a little bit above. So now can you tell where they overlap? Because that's what the final answer will be. This is where they overlap. And it doesn't have a side to it. Usually we have a third one, which will kind of like contain it. But this is the area where they both overlapped. To get that any point that's in there would satisfy both equations. It would work in both of the two equations I gave you. If I pick a point that seems like it would be in there, like 5, 5. If I go over 5 and up 5, it's like right there. That should work in both equations. Does it work in this equation? Yeah. 5, 5, the y part of it is 5. 5 is bigger than 1. It works. And then does 5, 5 work in this? I'm moving the whole thing. Dang. The other equation, which I can't pull out, but I'll show you, 2x plus 1. And it was less than or equal to, there we go. Does 5, 5 work in there? Here's how you can tell. You'll put in a 5 and a 5. That's 11. 2 times 5 plus 1 is 11. Is 5 really less than or equal to 11? Yeah, it is. So 5, 5 worked in that equation too. There. That's the new stuff for today. So what's your homework? I'll find it with you. So here's our worksheet. I'll scroll up to the top of it so you can see the name of it. Linear Programming Day 1. And we're going to do the evens. So number 2. X is greater than or equal to 3. Well, here's where 3 is. And that's the line X is greater than 3. You got to get used to which way is which. That's an X equals line. And now it's greater than, so I just shade just a little bit to the right of it. Remember me saying that you don't want to shade all over the whole paper? Because we're about to have 1, 2, 3, 4 equations on the same XY axis. It'll get so messy if you do that. Just a little shading on one side of the line works just fine. Okay, next. X is less than or equal to 7. Here's where 7 is. Less than means on this side of the line. If you have a straight up and down line, it's pretty easy to tell which way is less than because the numbers are smaller. Now, if I was done, the answer would be right in here, but I'm not done because I got to do more. I got to do the line. I'll do this in green. Y is less than or equal to 10. Well, here's 10 and less than that. Well, that's pretty easy. Just put the top on my little box. Last but not least, you'll graph this one, which is, I start at 8, and I have a slope of -1. Down 1 over 1, down 1 over 1, down 1 over 1. I hope you remember how to graph basic equations. If you don't, you can always make an XY chart, right? And you graph where it's equal to, and then you just shade on one side of it. So like again, you can use your best friend in graphing here if you want. If you want to stick in like an 8, you get 0. And so 8, 0 should be on this graph, and it is. It's right there. So, all right, and now which way do I shade on this line? Because this is greater than, I shade above. You're right. Now, the people that are more, I don't know, spatially inclined are going to be able to see this right away. There's my answer right there. That's where they all overlap. That's your final answer, is to shade that in. That's what we're looking for, is that little shape. And remember, by later in this chapter, we're going to know that one of these corners optimizes this set of constraints. One of the answers will always be the corners. and you'll just have to figure out which corner is best. You'll understand that better once they're word problems, and they're talking about, oh, X direction is like TV sets, and Y direction is like DVD players. And then you'll figure out which one makes you the most profit. Okay, that was a big day today. Your assignment is the evens on that. There is an answer key. There's no reason why you couldn't have this perfectly done by tomorrow, and I need more things in the grade book, so watch out. We'll be grading again soon. I'll have those tests graded for you tonight so you can see results tomorrow. That's all I got for you for today.